So let me first introduce myself. Yeah, so it's my first time to Washington, D.C. It's a great city. I'm from Taiwan, and I'm the founder of a cryptocurrency exchange that's called Carbonhood. And I'm a serial entrepreneur. I started my first company in college, and currently it's the fourth company. I exit 3 companies. Last one is Asia's live streaming company. It's called 70 Media. So it has the most of the daily active user, like 10 million daily active user, and sold to a group. Yeah, and after my exit my company, I got into the cryptocurrency space. So as I trade the cryptocurrencies, I found a lot of drawbacks. So I decided to make one exchange myself. And after I operate a centralized exchange, I found that we are in urgent need that we need to establish a high-frequency trading infrastructure, the trading settlement layer, that can support like thousands or millions of transactions per second and with low latency. So basically, it's a high-frequency trading settlement layer that's going to power the Carbonhood's decentralized exchange service. So that's why we at Carbonhood is developing the project called Dexon. So Dexon, we will shortly introduce, is infinitely scalable distributed ledger technology that is not even based on a blockchain. It's based on a block lattice. So let us first watch a video to understand how it works.
Most blockchain technology processes transactions linearly, block by block, so it's difficult to scale. To solve this, the fundamental structure of existing blockchain technology needs to evolve. Introducing Dexon, a revolution beyond blockchain technology. Dexon is based on a revolutionary block lattice data structure that features multiple blockchain systems working together in parallel. The Dexon network scales easily and automatically. Transaction processing power magnifies as the Dexon block lattice network grows, while maintaining low transaction fees, empowering decentralized applications to unleash their true potential. Dexon's visionary technology is also designed with interchain protocols so that other blockchain systems, such as Bitcoin and Ethereum, can be incorporated into the Dexon network, allowing for the fully decentralized transfer of value between different networks. Efficient, low latency, and infinitely scalable. Let's kickstart the decentralized future with Dexon.
So we have a concept which is called DApps. So everyone here should have known this name, right? The decentralized apps. So we actually have experienced the website booming era and then experienced the mobile apps. And then we have now come to the age of a DApps. But we actually haven't seen the DApps is being mass adopted. Then why is that? We can see from this picture, actually there is one very important concept is called a chasm that is blocking a new technology from mass adoption. So what is blocking the blockchain technology from mass adoption? Is the scalability problem and the transaction latency problem and the high transaction fee problem. And moreover, you have energy inefficiency and the decentralization issue. So we first need to resolve these issues before we can talk about a mass adopted DLT, decentralized ledger technology. And that's why we at Dexon Foundation is working on this. So Dexon consensus algorithm is an infinitely scalable, low latency with Byzantine fault tolerance block lattice. And how it works is like, you can actually see from the left-hand side is a traditional blockchain data structure. So the blockchain grows block by block, and it sometimes creates an orphan block. So orphan block is not on the longest chain and wastes energy. But on the right-hand side, we have a block lattice. So the block lattice actually grows in parallel and is non-blocking. It doesn't have to wait for any other node. So each node operates its own blockchain and grows non-blockingly. It doesn't have to wait for any other node's information, and it can grow continuously. And you can see from the image is they have like cross links between different blockchains that we call hacking. So through this hacking, we can aggregate like if you have 10 nodes that's proposing the blocks in parallel, and through the hacking information, we can guarantee a consistent compaction chain. It's like I grow like 10 blockchains in parallel, and later with an algorithm, we can guarantee the 10 nodes or the honest nodes, the non-Byzantine nodes, can generate a globally ordered chain. Yeah, so it works just like a MapReduce. We first fan out to a lot of nodes and then merge all the nodes blockchain into a single chain. So that's the idea, to make it infinitely scalable. So actually you can have an arbitrary number of nodes in this system, and the latency of the finality is like 1 second, as you will see of our simulation result. And because of the scalability is very high, your transaction fee becomes arbitrarily low. So we first need to understand the fee. Fee structure is average is the cost for a miner to produce a block, and per transaction is cost to produce the block over the number of transactions in the block. So if your block producing a transaction per second is very cheap, it's very cheap to produce a block, then you won't have very high transaction fees, right? Yeah, and this system is provably secure. By provably secure, we mean like rigorous proof on Byzantine fault tolerance. So it is not like proof of work blockchains, which we call them is probabilistic final. So we have longest chain, but longest chain can always be overwritten. It's possible to be overwritten. But on the Byzantine fault block lattice, you can never rewrite the history. Yeah, so in terms of the latency, you can see this is infinitely scalable and under 1 second, and your transaction fee now becomes negligible. Yeah, in terms of security, it's Byzantine fault tolerance, so it cannot be double spent. And another thing to note that is it's also resilient to a denial of service attack. So denial of service attack actually comes from when you have a single block producer in a typical DPoS system. At each time slot, you have a single block producer. So if that producer can be predicted and be DDoSed, it will be ruined. Yeah, it just happens like in EOS and Cardano system. It's a transition of the block producer. Firstly, it's predictable, and another thing is at each time slot, it only has one producer. Yeah, so actually this double spend attack does happen. So just like last month, we got 3 coins under this attack. So they lost like 20 million or above each coin. It's like you deposit a lot of coins into an exchange, and the deposit history got rewrite. And then the funds are stolen. Yeah, so how does that happen is because any blockchain system that's based on proof of work will be vulnerable to this kind of attack. especially a newly launched chain. So new launch chain, because its hashing rate is fairly low, so some malicious miners can borrow a lot of hash power and secretly grows a longer chain. And then after that, it reveals and rewrites the history. So we call this a selfish mining attack. Yeah, so actually you can see from our simulation result, the Dexon block lattice from the left-hand side, you can see the latency. The kappa is just a parameter, it can be tuned. So basically, in practice, we will choose kappa equals to 1. So you got the finality latency around 1.2 seconds average. And the best case, it will be about like 700 milliseconds to confirm one transaction. Yeah, universally. So you can see the formula is TPS actually equals to the number of nodes minus T transmit times T transactions per block. Because we introduce one variable, the T transmit, it means how many blocks 1 sec per second that a node produces. So in this setting, each node is producing 2 blocks per second. And if we have like 25 nodes, then we can reach 50 blocks per second, and 1 block is 1 megabyte, and the average transaction size is 100 bytes, then you got a 5,000 KTPS. Yeah, so we made this system to make the decentralized ledger technology to become mass adoption ready. And we envision the future to, we will foresee a dApps booming era will begin with Dexon. Because only if you have this infinitely scalable data structure, then you can bring in the traditional internet companies. Why they haven't moved into this space? It's not because they don't know this technology is booming. It's because they haven't found a solution to let them migrate their millions of daily active users or tens of millions of daily active users onto this technology. And once this is made possible, the world will just be changed. And Dexon is already being invested by IDG Capital, and Carbon, who is decentralized exchange partner. Okay, so the application scenarios is pretty diversified. We have IoT data trading network, supply chain management, fintech, payment networks, decentralized marketplace, payment network, asset exchange, and prediction markets. And Dexon also have its lab that invests in new projects that will be launched on Dexon network, and it has an incubator. Yeah, so basically this today's sharing. Does anyone have any questions? Selfish mining. Yes, so we first need to understand that only proof of work system will be vulnerable. Like proof of stake system, you actually need the stakes. So the problem is transferred to, one problem is called nothing at stake attack. So to avoid that kind of problem, you enforce a time lock period of your stake before it take effect into transform to a voting right. Yep. So basically, you can think of Dexon also like a transform of proof of stake. It's not based on a proof of stake. It's a more advanced algorithm, but we won't explain it in detail here.